Hello and welcome back to the Linux Panic YouTube channel. This is video 7 of my Linux from Scratch stable LFS version 11.2 series. Where we'd previously left off in chapter 9, we had just finished with the configuration of the system and now we're coming up to making it bootable. So the first thing we want to do is we want to come to chapter 10.2 and creating the file system table file. So to do that we just copy this, copy the first section here, create it, create the file, and we want to do vim/etc/fs tab. And what we have here is our file system table file that we will need to edit to begin with. So the first thing we need to do is we're going to do Control-C UI, clear the screen, and we want to do ls. We want to do blkid. And what this will do is it'll give us the UUIDs, or the unique identifiers of the partitions that we're going to need. Now, this is important for making sure that we set tables correctly and we do not accidentally break things. So in my case, the boot partition is this UUID. So I'm just going to copy this. Okay, so just boot. That's the boot boot UUID. This is the swap UUID. And this one here is my rootfs, or where everything goes. I'll just call this rootfs. Save that UUID. So once we've done that, we clear this. We want to do vim/etc/fs tab. And what we have here is what we need to do. So first things first, we want to set our swap partition. So get rid of this entire line and replace that with the UUID. Now what this will do is this will ensure every time the system gets booted that this is set correctly, so we don't break anything, for example. This is just there as a safety net, which is what we want. We've just put in the swap. We now need to put in our boot partition, our rootfs partition even. So we're going to copy this, come to here, all the way to here, remove this, and paste that in. Because I accidentally kept in the rootfs, it does not know what to do, but that is set correctly. And what we need to do for that is we need to set the file system. In this case, it's just going to be ext4. ext4, which is what we want. And finally, we need to set our boot. To do that, we're just going to copy the UUID once again. Come to here, paste in the UUID with the correct quotation mark. Come to here, and this will be /boot. Come to here, as we set this earlier on, it's ext2. I'm going to come to here and just do defaults, comma, no auto. Come to here, and we want to set this to 0 for dumping and 2. So now we have a accurately set driver boot party file system table. So this UUID links to the boot, this links to the rootfs, and this links to the swap. So every single time the system boots up, it won't look for a drive letter. It won't look for SDAB, or VDA1, VDA2, VDA3, or SDA1, SDA2, or SDA3 for you, or whatever your markings are. It'll look for the unique identifier, and in this case these are the ones, so it knows that every single time if it finds that, it's safe, which is what we want. I need to come down to here and then swap that for that. Said Control-C, Control-C, right to quit, and then exclamation mark. And if we do cat/etc/fs tab, we have everything is set. If we do blk ID, so block ID, for boot, it ends with A55A. That is correct. Our swap ends with 3D36, and our root FS should end with FF95, FF95. Which means we have got this set correctly. Which means we can now move on to the next step. This here just gives options for like how you might want to set things. But in this case, we've set everything correctly. It is possible to make the ext3 file system reliable across power failures for some hard disks. Do this, add barrier equals 1 mount option to the appropriate entry in the FS tab to check the disk files. But because we're not using anything ext3, we won't be touching this. Now what we need to do is we need to go back into the sources directory, so cd sources, and we need to once again re-extract the Linux kernel. So to do that, it's just r-xvf Linux, extract all of that. Again, this is a rather large size. So what this is saying here, it could take anywhere between 1.5 standard build units and 130, depending on what you've chosen. And this is the approximate size based on what you've chosen. But once that's done, we need to cd into the directory, make Mr. Proper, and now make menu config. Now, what we need to do first is not do make menu config. We need, if I can find it, there is a way to make a configuration that is set for your system. If I can just find it. Not make config. Can't find it now. Either way, that's fine. So once we've made Mr. Proper, we're going to go make menu config. And now we have our kernel configurator. So what we need to do is we need to come to here and make sure that these are set. A good starting place is to make one for def config. So we exit. No, we don't want to save that. Is we want to do make def default config. So make def config. That'll make one based off this system. To make menu config. We now set up properly. So what we need to do is we need to be sure to enable, disable, or set the following features, or the system might not work. So what we need to do is we need to go to device drivers and then frame buffer setting, frame buffer devices, and then support for frame buffer. So that there. Want to find device drivers. Find device drivers. So device drivers, and then frame buffer devices. Go find the frame buffer devices. Wherever that may be. LED support, InfiniBand support. If we do, I was going to say we could do a search, but apparently I was searching. Oh, yeah, so it is just that. So that just gives you the option of selecting. But if we do that and we want to look for frame buffer devices, so I can't find that, but that's fine. So once again, it's just device drivers, graphic support. So I've most likely probably gone way past graphic support, so it is worth making sure you are going into the correct place. So that's fine. So frame buffer devices is under graphic support, so we need to find the graphic support first. The block devices, NVMe, MISC, SCSI, serial ATA, multiple fusion, IEEE, Macintosh network, input character, I2C, I3C, SPI, sorry, I2C, I3C, HSI, PPS, PTP, pin controllers, GPIO, Dallas, where is the graphics support? Graphics support. Then we need to come down to frame buffer devices. So here we could actually add in support for Intel or NVIDIA graphics cards or AMD graphics cards or ATI Radeon, because you've got to remember, even though AMD own ATI Radeon was a thing separate from AMD before AMD bought ATI Radeon, so that's why there is ATI Radeon support there, because that was a thing before AMD bought them up. But we need to find frame buffer devices. That is somewhere here. We will find frame buffer devices and then make sure that we have support for frame buffer devices. So we leave that with an asterisk. Do exit, exit, exit. No, I do not want to leave. I didn't set the things correctly, so now we have to go back to do that. Let's try not to do that again. So device drivers. It is under graphic support and then support for frame buffer. Frame buffer devices, support for frame buffer. So with that being an asterisk, that will enable support for it. With it being an M, it's only a module, but we have this set correctly, so this is fine. We now need to make sure that under general setup, the compile with warnings as errors and enable kernel headers through that is not enabled, so we need to go back again. We need to make sure we're not in the wrong place, or make sure we haven't gone too far back. Okay, this is good. General setup, and then compile with kernel headers, kernel warnings as errors. We need to disable that, and then we need to disable kernel headers through syskernel. So we need to find that, and that is not enabled, which is good. Back once more, and then generic device driver options, which would be under device drivers. So we need to go back to device drivers, and then it is generic driver options. We've got to find that somewhere through the list. Generic target. Finding it's going to be the hard part. Multimedia support, graphics support, HID, USB. We can actually have a quick look at the USB devices. There's a lot here, because if we remember looking at the output from extracting the kernel, extracting the Linux directory, there was a lot of information there. Right now we just need to find generic driver support, generic power cap, reliability, Android options. We could add Android drivers if we wanted to. NVMEM support, FPGA configuration. Now we just need to find generic driver options. So driver options. Well, it's in device drivers, we just got to find it. So EISA, PCI, PCC, generic device driver options. I can't believe I went straight past that. We need to make sure that support for U-Event helper is not enabled. So support for U-Event helper is not enabled. Maintain a dev temp file system at dev is enabled, and then auto mount a dev temp file system at dev after the kernel mounted to the root FS, which is done. We're going to go back and then back once more. And now we need to enable some additional features if we're building a 64-bit system, which we are. Gonna have a sip of coffee first, so we need to do them in this particular order, and a sip of tea even. We need to do config PCI MSI first. That is under device drivers, PCI support. We need to find, once again, device drivers, PCI support, and then it is message signaled interrupts. The PCI support, and then it is message signal interrupts, and make sure that is enabled, which, as we can see, it is. And then we need to go to, and then config PCI first, then config IRQ remap, which is under IOMMU support, hardware support. So we need to find IOMMU hardware support. Let's go back one. Make sure we haven't gotten too far out, which we haven't. We need to find IOMMU hardware support. Find it eventually, I hope. DFIO, Microsoft Hyper-V guest support, we don't want that. IOMMU hardware support, and we need to make sure that support for interrupt remapping is enabled. We need support for interrupt remapping is enabled. And we need to go to config x86x2 IPAC, which is under processor types and config, processor types and features, and then it is support x2 APIC. So the reason why it's saying to go through various steps is because of how the options are enabled after you selected a few other options. But now we've got this, that's fine, and we can now make changes if we wanted to. We can have a quick explore around the system if we wanted to before leaving. So let's just say how kernel hacking. This is just options it gives us. Debug oops, lockups and hangs. That's rather funny. But these are options we could have. Let's have a look at if we can't find any miscellaneous options, shall we? It'll be on the device drivers and then probably all the way down at the bottom. No miscellaneous options, so that's fine. But other than that, that would be enough. So let's just do exit. Yes, I want to save. That's now been done. And we now need to make the kernel image, so it's just going to do time and make 4. And that is now going to build the entire kernel with all the entries and changes we've made. So this may take a little while, so I will return once it has finished compiling. Okay, so now that we have finished compiling the kernel, we need to enable module support if we have modules. So this, because we haven't changed much more other than what was required, it is likely that we have modules, as we can see here. There are some thermal modules for Intel. There is some EFI stuff. There's some IP version 4 and some filters. So we can clear this and we can move on. After kernel compilation is complete, additional steps are required to complete the installation. Some files need to be copied to the boot directory. If the host system has a separate boot partition, so the host system, not the system we're building on, that's fine, because we're not going to be using our host system and we're just currently booting from an ISO. This is fine. The path to the kernel image may vary depending on the platform being used. The file name below can be changed to suit the taste, but stem from the file name should be so the first part has to be VM Linux to make sure it is compatible and will run. We'll do that. System map is a symbol file for the kernel. It maps function entry keys, function entry points for every function on the kernel API. So it's just a mapping, which is what we need. Configuration is produced by the make menu config step and contains all the configuration selections for the kernel that was just compiled. It's a good idea to keep this for future reference, so we will do that. And this is just installing some documentation, so we'll just copy paste this in and copy paste that in, and we now have our extra documentation. In many cases, the configuration of the kernel will need to be updated for packages installed later on in beyond Linux from Scratch. Unlike other packages, it is not necessary to remove the kernel source tree. Let's just add a sip of tea. If the kernel source tree is going to be retained, run chown -r00 on the Linux 5.19.2 directory to ensure all files are owned by the root user. So in this case, we will just copy this and paste this in. So operation missing, so that's fine. So we need to do and if we do ls-la, as we can see here, all are owned by root, which is what we want. We can clear this. And if we have modules that need to be loaded in a particular order, this is what we would do. But because we don't have any modules, we can just leave this alone. And we can now move on to using grub to set up the boot process. If your system has UEFI support and you wish to boot LFS with UEFI, you should skip this page and configure grub with UEFI support using the instructions provided in the Beyond Linux from Scratch page. But because we don't need to, well, we can go through this part anyway. Ensure that an emergency boot disk is ready to rescue the computer if the computer becomes unusable, aka unbootable. If you do not already have a boot device, you can create. So this is just making an extra bootable image if we need it, but we're not going to because we don't need it. Well, I don't need it. If you do, follow that instruction, but because I don't, I'm not going to. Install the grub files into boot/grub to set up the boot track, using the above information to determine the appropriate designator for the root partition or boot partition if a separate one is used. For example, it is assumed that the root or separate boot partition is SDA2, but because it's not, and we do have to be careful here because I'm using a separate virtual machine, so I'm just going to CD back down. And we need to paste this in, but it's not dev SDA, it's dev VDA. And this is just installing 32-bit architecture, that's fine. The installation has finished without issues, which is good. We now need to create our boot configuration. We just need to copy all of this, paste this in, and we need to do some editing with that first. So we need to do vim/boot/grub/grub.cfg, grub configuration. Note, from grub's perspective, the kernel files are relative to the partition used. So first thing we need to do is just make sure we do lsp OK. We currently have 3 installed. We're going to do clear, and that's fine. So what we need to do is we need to make sure things are set correctly. So we need to set the root of disk being 0, and it's assuming that the partition is set to 2. So it's looking for boot/vmliners. So that's fine. We can just leave that alone. That's just going to be read only. But what we do need to do is we need to come down here and change this from a SDA to a VDA. So we're just going to do insert VDA. If this doesn't boot, then it might be looking for the boot partition. And in that case, it's just go and change it, which is fine. So we're going to do Control-C, right quit W, and ls-la to find a boot. There's our boot partition. That's fine. And move on to the end. So that I'm going to move on to the final part. So the end. Well done. The new LFS system is installed, and we wish you much success with your shiny new custom-built Linux system. It is a good idea to create a etc/lfs releases file. By having this, it is easy for you and for us. If you need to ask for help at some point, we're just going to do that. 2 files describing the installed system may be used by packages that can be installed on the system later, either in binary or form of building them. The first one shows the status of your new system with respect to the Linux standard space. To create this file, run this. So this is where we can add our stuff in. So your name here. So I'm going to put Linux Panic here. And now we can just scroll all the way to the end, hit enter. And the second one contains roughly the same information and is used by systemd in some graphical environments to run this file. Create this. So I'm going to then put your name here. So in this case, Linux Panic. Go to the end, put that in. So we have changed this. Be sure to put some customization in the fields distribution code name and the version code name. So we did distribution code name and version code name, which we have. I've already got myself counted. So we can now move on to the point where we reboot the system. I will make this another video within itself so we can see from the start, from start to finish of booting. But that is it for this video. If you made it this far, maybe consider hitting the like and subscribe button. If you disliked it, hit the dislike button. Maybe leave me a comment. But anyway, I've been Nick, you have been amazing, and I hope you have a good rest of your day. Goodbye.